Welcome everybody. Our lesson today will be about Lever's law. But first, we should know some definitions. First, the effort arm. It is the distance between fulcrum and the effort force. The resistance arm. It is the distance between fulcrum and resistance force. There are three types of levers. First class lever. In first class lever, fulcrum lies between effort force and resistance force. In first class lever, the effort arm may be more than resistance arm, or effort arm equal resistance arm. If the effort arm is more than resistance arm, the lever will save time and effort. It means save our time and our power and energy. Examples: the hammer. If we measure the resistance arm, and then the effort arm, you see the resistance arm is shorter than the effort arm, so hammer save time and effort. In the example of the seesaw, if we measure the effort arm, then resistance arm, you observe that the effort arm equal resistance arm, so seesaw doesn't conserve time or effort. Here in pincer, resistance arm is very short and effort arm is too long, so the effort arm is longer than the resistance arm, so pincer save time and effort. In plier, resistance arm is shorter than effort arm, so plier saves time and effort. In scissor, if we measure resistance arm, then measure effort arm, you observe that they are equal, so scissor doesn't save time or effort. In nail clipper, resistance arm is very short, effort arm is too long, so effort arm is longer than resistance arm, so it saves time and effort. In the paddle, resistance arm is equal to effort arm, so it doesn't save time or effort. Let's transfer to some questions. Give reason for. Sometimes first class lever save time and effort because the effort arm sometimes is larger than resistance arm. Now we reach to the second class lever. In second class lever, the resistance arm lies between fulcrum and the effort arm. Notes: in second class lever, effort arm is always larger than resistance arm, so it always saves time and effort. Examples on second class lever: nutcracker. If we measure the resistance arm and effort arm is larger than resistance arm, so it saves time and effort. In the bottle opener, here is effort arm and resistance arm. The effort arm is larger than resistance arm, so it saves time and effort. In the wheelbarrow, the effort arm is larger than resistance arm. Here is the effort arm, and here resistance arm. It's clear that resistance arm smaller than effort arm, so it saves time and effort. In stapler, here is effort arm, and here is the resistance arm. Effort arm larger than resistance arm, so it saves times and effort. Give reason for the second class lever are always save time and effort, because in second class lever effort arm is always larger than resistance arm. Now the turn of third class lever. In third class lever, the effort force lies between resistance force and the fulcrum. Notes, in third class lever, resistance arm is always larger than effort arm, so they always doesn't save time or effort. Examples: ice holder. Here is resistance arm and effort arm. Resistance arm is larger than effort arm. It doesn't save time and effort. The same coil holder. Resistance arm, effort arm. It's clear that effort arm is larger than resistance arm, so it doesn't save time or effort. Switch holder is the same. Resistance arm, effort arm. Resistance arm larger than effort arm, so it doesn't save time or effort. Manual broom. Here is resistance arm, effort arm. It's clear that resistance arm is larger than effort arm, so it doesn't save time or effort. Here, hockey bat. Resistance arm, effort arm. It is the same, doesn't save time or effort. The fishing tool is the same. Effort arm and resistance arm, so it doesn't save time or effort. Give reason for the third class lever doesn't always conserve effort or time, because resistance arm is always larger than effort arm. It is the time to solve some questions. Complete the following statement. In third class lever, the effort arm is space the resistance arm. Smaller the resistance arm. In second class lever, the effort arm is the resistance arm. The answer is more than resistance arm. The lever which always save time and effort. The answer is second class lever. Write the scientific term. A lever in which effort force lies between resistance force and the fulcrum. The answer is third class lever. A lever in which fulcrum lies between effort force and resistance force. The answer is third class lever. A lever in which resistance force lies between effort force and fulcrum. The answer is second class lever. A lever always saves time and effort. The answer is second class lever. Give reason 4. First class lever may save time and effort because sometimes effort arm larger than resistance arm. Number 2. Second class lever always save time and effort because effort arm is always larger than resistance arm. The third class lever don't always save time and effort because resistance arm is always larger than effort arm. Nutcracker from second class lever. Because resistance lies between effort arm and fulcrum. The lever law. The lever's law said the effort force times effort arm equal resistance force times resistance arm. To simplify solution of problems, we could use this shape. You hide something you want to calculate, as if you want resistance force, you hide it, then resistance force will be equal effort force times effort arm divided resistance arm. If we want effort force, we could hide it, so resistance force, effort force will equal resistance force times resistance arm divided effort arm. The same if we'd like to know resistance arm, it will be effort force times effort arm divided resistance force. If we'd like effort arm, it will be resistance force times resistance arm divided effort force. Solved problems. A lever of effort force 50 Newton and effort arm is 40 centimeter. If the resistance arm is 20 centimeter, calculate the resistance force. Resistance force will be equal effort force times effort arm divided resistance arm. It will be equal 50 times 40 divided 20. During solution, we should determine the data which we need. Effort force 50 Newton, and effort arm 40 centimeters. Resistance arm is 20 centimeter. Then make a decision about what we need. Note, any force, the unit of it should be Newton. Let's turn to the second problem. A lever of effort arm 6 centimeter. If the resistance is resistance force 220 Newton, calculate the value of effort force if the resistance arm is equal 20 centimeter. Effort force equal resistance force times resistance arm divided effort force. 120 times 20 divided 60 equal 40 Newton. The third problem, a lever of effort force 100 Newton and its arm 20 centimeter. If the resistance force is 400 Newton, calculate the resistance arm. Mention the type of lever. This will be homework for you. You will find the sheet of the lesson under the description of the lesson. Goodbye and thank you.